Hello everyone and welcome. Today we're going over a problem we went over yesterday. And yesterday we did a or solving for pressure. Yesterday we were solving for pressure and the pressure needed to lift the piston in bar. So, we have the piston's weight and the pressure in atmospheric bar. Those are two forces pushing down on the piston, but it is stopped by these stops right here in pink. And so we're looking for the moment of impending motion. That is the second the piston moves, a nanosecond, whatever. And that happens when the gas force is equal to the force of the piston and the atmospheric pressure. So, with constant heat, pressure is we are increasing pressure within the gas, and the moment the pressure reaches the force required, it goes up. And the reason, or another reason, or the reason, yeah, that the volume would increase and not the pressure at some point, is because the moment pressure is equal to that force, pressure is actually constant at that point, unless there are stops on top, or just it's a rigid tank in that manner. So instead, volume would increase rather than pressure, because that pressure, extra pressure that it wants to increase, would go towards expanding its volume. So yeah, that is an expansion, which later on we have to draw. But anyways, we need to solve this problem with the force balancing equation, since, as I said, we're looking for the moment that the pressure of the gas is equal to the bar and the piston weight. And that is what I have here. So the weight or force of the piston plus the force of the atmospheric pressure must equal gas, and that's the moment of impending motion. And that is how we get our pressure required to lift it in bar. Because, as I said, pressure is equal to force over area. And then we just flip-flop that equation. We just move it around in order to get what we need. So that is what I did in this case, as we go here. But anyways, we first started off with solving for the weight or force of the piston, which is mass times grams. Weight is a force, mass is something else. So, with our mass of 50 kilograms times the force of gravity, meters per second squared, we know that these units are really important and translate into newtons. So knowing that, you simply just multiply the 50 and your 9.81 and convert your units to newton to get your force/weight of the piston. Pretty simple. Now our second step was using this pressure with this force over area equation, which is pressure, and finding the force, since we are given the pressure in bar and the area. And as I said here, our area can change, or we sometimes have to subtract area depending whether there's a shaft or anything like another external force, such as the shaft in that nature, taking away from the area that the atmospheric pressure is applying to. So in this case, there's no shaft or anything in that sort of nature. So you're dealing with just the circle, just a face, and your total area, so you need to make no changes to that. And also, you don't need to solve for area, which is either given in radians or degrees, however you want to solve for it. And also, if you're given, I guess, sorry, I meant radius or your diameter. Yeah. And so diameter is just, radius is just diameter in half. So If you don't want to remember this and you feel more comfortable with that, just divide your diameter by 2 to get your radius. But anyways, you're given your atmospheric pressure, which is 1 bar, and then the area, 0.01 meters squared. And so, in order to get newtons in this scenario, you need to convert your bar to Pascal, and the unit conversion is per every 1 bar, you have 10 to the 5th Pascal. And Pascal, those units are just Newton over meter squared. And so doing some cancellation with the unit conversion ratio, we are able to multiply 1 bar by 10 to the 5 Pascal, and we know that's just Newton over meter squared. And so with this 100,000 Newton meter squared, we multiply the meter squared from the area, giving us just Newton, which is perfect since we are solving for the force of the atmospheric pressure. Which is right here. The values just multiplied, and then here are the units for our final answer of the atmospheric force. And now, we must find the force of the gas. And simply, you just add your two forces, which you solve for, and you get pretty simple 1,490.5 newtons. And so now here's what I was talking about. Using this force and the area, we are solving for the pressure in bar required to lift the piston. So we have the force, and we have the area, which I said is just a circle, nothing obstructing it, so you don't need to subtract the area from anything. Or you don't need to subtract, anything from your total area. But anyways, your pressure is just, as I said, your force of gas over the area at which the gas is applying pressure or force to. So yeah. And we know that Newton meter squared, as we transformed here, is just Pascal. And Pascal, we know that it's 10 to the 5th is equal to 1 bar. 10 to the 5th of Pascal is equal to 1 bar. So using that conversion, we multiply our unit, Pascal, times 1 bar over 10 to the 5th Pascal. This is just how to convert. And that's how you get your final answer. So you're essentially just dividing this by 10 to the 5th Pascal. And your Pascals cancel, and you're left to multiply 1 bar to the whatever you get from dividing this by 10 to the 5th. And that's your final answer. 1.5 bar rounded for simplicity. Thank you.